Okay, this is continue on with the exponential functions section, and we are going to be doing the one-to-one property with the exponential functions. So the one-to-one property definition is you have a to the x equals a to the y if and only if x equals y. So basically what it is the bases must be the same. So you have an a here and you have an a here. If you have the bases as being the same, then you can set the exponents equal to each other. So set exponents equal. Then what you're going to do is solve the equation for x. So I'm going to do a couple examples to show you how this works. So here's the first two examples. It says use the one-to-one property to solve the equation for x. First thing you have to look for is are the bases the same? So if you look at the first example, you have 5 to the 2x plus 4 equals 5 to the 3x plus 6. So both of these bases are the same. Since the bases are the same, you can just set the exponents equal to each other. So you get 2x plus 4 equals 3x plus 6. And then you just have to solve the equation for x. And you should get x equals -2. Okay, the next example, you have to make sure the bases are the same. So 3 to the x minus 5 equals 3 to the 2x plus 7. Bases are the same, so you can just set the exponents equal to each other. And for that one, you should get x equals -12. Okay, now we have two examples where the bases aren't the same. So this is where you have to make the bases be the same. So take a look at your bases. You have a 2 and an 8. So basically what you need to do is rewrite this 8 with a base of 2. So what you're asking is 2 to the what power will get you 8? And that ends up being 3. So do you see how 2 to the third is the same thing as 8? Now I have my bases as being the same, and so therefore you can set your exponents equal to each other. So you can set 2x minus 1 equal to 3. And then solve it for x. Okay, so if the bases are not the same, you need to make the bases be the same. So you're going to have to somehow figure out what base needs to go, what exponent to get that number. So if we take a look at number 4, you have 9 and 3. So what you're asking is 3 to the what power get you 9? And that would be 3 to the second. So if I rewrite that, now you have your bases as being the same. and you can set your exponents equal to each other. Okay, so you were kind of asking yourself, how can the number be written with an exponent? Okay. All right, these last two examples is when you have to change both bases. Okay, so this is changing, oh, I don't know what happened there. Okay, there you go. Changing both bases. So if we take a look at this first example with number 5, you have 1/2 to the x equals 8. So basically what you're trying to figure out is how are 2 and 8 related to each other with exponents. And if you can think about it, 2 to the third is 8. So we're going to use the base of 2 to rewrite this. So now you're thinking, well, how do I get 1/2? If you remember back to algebra with rules of exponents, 2 to the negative 1 would be flipping it over the fraction bar. So 2 to the negative 1 gets you 1/2. But then you also have that extra x, which we'll talk about that. Then I need to rewrite the 8 as 2 to the third. Remember, you say, 2 to the what power will get you 8. 2 to the what power will get you 1/2. Now that I have my bases as being the same, you can set your exponents equal to each other. But what I have here is I have -1 times x, so that's just going to be -1x equals 3, and then I can solve. Okay, for number 6, you have 4 and 32. If you think about it, 4 to the what power gets you 32, that won't work. So we have to think of another base that goes with 4 and 32, and 2 works. So 2 to the what power will get you 4. Then you have to remember that you have that extra 2x there. So 2 to the second power will get you 4, and then you have that 2x. So if I come over here to the 32, 2 to the what power will get you 32, and that would be 5. But then you add that extra 3x plus 6. Now that I have my exponent or my bases equal to each other, you can set the exponents equal, but you're going to want to multiply there. So you should end up getting 4x equals 15x plus 30. Subtract the 15 over, and you get -11. And then you should end up getting 30 over -11. Okay, so with these ones, you have to change the base for both of them. And you just have to think about what numbers that both of these numbers go into and how they are related to each other.